Hey guys, today we're going to be talking about adding and subtracting in linear inequalities. Now, we're not adding and subtracting the linear inequalities themselves. We are adding and subtracting in the linear inequalities. So we're going to be doing problems like this one. X plus 7 is greater than 3. Looks pretty straightforward, right? It looks like a one-step equation. The only thing we have to do is get that x on its own, just like we did in one-step equations. And we do that through utilizing inverse operations. Again, just like we did before. Is there really anything different to this at all? To be honest with you, not much. Here's the deal. We're going to treat just about any inequality just like an equation where we act like that's an equal sign until it becomes important. And usually that's all the way at the very end of the problem once we've already solved it. So I'm going to say, I want to get this 7 moved over to the other side. It's currently adding, so I'm going to subtract. Well, that cancels these out, leaving x on its own. And I say x is greater than 3 minus 7, or negative 4. Well, look at that. We're done. We got x on its own. We have a single number on the other side. But instead of an equal sign, we have this inequality. X is greater than negative 4. So x is any larger number. Now, a lot of times what we actually want to do is plot inequalities on a number line so that we can kind of visualize what this statement is saying. So here's how we want to write that. On a number line, I'm going to go ahead and mark negative 4, and then I'm going to put some number on either side of it, right? Negative 3, negative 5. And those work because they actually are on either side of it. Now to graph this, to denote this visually, what we're going to do is we're going to put a circle around the number that x is greater than, less than, whatever it may be. So I'm going to put this open circle right there. Now, if it is an or equals to sign, then we fill in the circle. A filled in circle denotes on that number line that the x can be equal to that number, that it can be negative 4 in this case. However, since we do not have an or equals to, we keep the circle open. This denotes that x can be right up next to it, but not quite negative 4 itself. We're then going to put an arrow in the direction that points the way the inequality tells us. So if we know x is greater than negative 4, we are going to make that arrow point towards the larger or the greater numbers. Now, of course, the greater numbers are over here on the right-hand side of a number line, negative 3, negative 2, negative 1, that kind of thing. So we're going to have this arrow, and it's going to point off over in this direction, saying, it goes on forever up there. X can be any number on that side of the number line as it gets bigger and bigger and bigger. But it can't be negative 4, and it can't be anything less. Now, this kind of tells us we can choose any number on that side of the number line, plug it into our equation, or our inequality, and it should remain true. So let's choose some number over here. Let's say a number larger than negative 4. I don't know, let's go with 5. That number's larger than negative 4, right? If we plug it into our equation, inequality, then we can see if we're right. We can check our answer. So instead of writing x, I'm going to write 5. Then plus 7 is greater than 3. Well, 5 plus 7 is 12. And is 12 greater than 3? Absolutely it is. So our inequality was proven true. And we would prove it true with any number we choose on that side of the number line. Let's do one more example here. Let's say we want to do x minus 12 is less than or equal to 9. So then, what would we need to do here? Now, we just have a one-step equation, inequality. We want to get that x on its own. Since 12 is subtracting from the x, we go ahead and do its inverse operation of addition to move it to the other side. Cancel those out. And we get x is less than or equal to 9 plus 12, or 21. So now this tells us x is smaller than 21. So it can be any number less than 21. 15, 10, 5, 0. But it does say or equal to. So x could also be 21 itself. If we want to denote this on a number line, then the way I personally like to do it is just listing that number that we have on the opposite side of the inequality, and then the numbers right around it. Depending on what teacher you might have, they may have different expectations of the number line, but in general, the idea will be the same. We put a circle at 21 here. But what are we going to do with that circle? We're going to fill it in. The reason we fill in that circle is because it is or equal to, right? And then we are going to take from that circle, or that dot at this point, and draw a line in the direction denoted by our inequality. If x is less than 21, then we are going to make that arrow go towards the smaller or the lesser numbers. And we want to make sure we put an arrow on the end of that, denoting that it goes on forever. All the numbers off to negative infinity could work for us. And to check our answer, we can choose some number less than, let's say 20 in this case. And if we plug that in, 20 instead of x minus 12, well, 20 minus 12 is 8. Is 8 less than or equal to 9? Absolutely, it's less than. If you guys have any questions about this, feel free to drop them in the comments below. We're going to have a second video that talks about what to do when we have multiplication or division in inequalities. And that is worth watching because there is something kind of special we have to do sometimes. All right, guys, thanks for watching, and I'll see you next time.